I just want to set a spot of context. So I probably drove your very first car when you were based in Cheshire. Going back, this must be 10 years ago now, right?
Yeah.
What's quite nice about this is I'm very honoured to be, I think, one of the first people to see your brand new car.
So
I think it's come around well.
So I guess the biggest obvious change is the look of the car, and of course, mono being mono, it's always going to be an evolution from that first shape that you saw and everyone's familiar with from 9 years ago. But it's the aesthetic really that is the first striking thing. Every single body panel on the car has been redesigned, contains graphene as part of our continuous innovation push with graphene, which helps to make the panels strong, which therefore means we can make them lighter, which helps towards the whole weight save. So the whole look of the car has completely changed, and I think the best place to start is probably at the front, because the front really is the most defining element of the car. So at BAC we're very particular about efficiency in design in everything we do, whether it's the aesthetic or whether it's designing components or systems on the car. And so the brief really from the appearance was to try and reduce frontal area, and so to that end we've got this kind of shark nose at the front of the car, which helps to divert airflow in and around the underbody of the car, and then obviously through various different elements and obviously to the radiators on the car.
I mean, seeing this front compared to the previous gen I've just walked past, it's so much more open.
Yeah, absolutely. So we've got this nature-inspired front here, where, you know, very uniquely, we've got the main beams are positioned here. That was very much inspired by the GTE racing category that you get at Le Mans. We've obviously got the conventional lights that are positioned here, but as part of this declutter of the front end, if you like, was to move those elements down into here. So you'll see that we've gone from 4 lights that were here down to 2 now, and then the main beams are down in the front. So that's the main first striking thing with the car.
I mean, that's the first time I've seen that applied to anything with a license plate. That looks awesome.
Yeah, and again, I think it's part of this influence that we have from motorsport, and then also from nature and so on and so forth. So the height of the car has been reduced, so the ride height has remained the same. So from a practicality perspective, the ride height is pretty much the same as the previous car, but the height of the car has been reduced by about 20 millimeters, and combined with what we've done at the rear, you'll notice that the rear of the car has almost been pulled outwards towards the rear. Effectively, what Ian and the guys have managed to achieve is that the car looks a lot lower, a lot squatter and longer. So it's all about this proportion change to do with the car. And I think that, combined with the fact that the engine is now making more power, we'll come to the engine shortly. But the engine makes more power, it makes more heat, it needs more cooling, so therefore the radiators are bigger. So if we look at the proportion of the car in terms of what we call the lower body to the upper body, you'll see that the whole proportion has got bigger here in order to house these bigger radiators.
It's got a serious footprint about it, hasn't it?
Absolutely, yeah. Awesome. Yeah, it really does. It really does.
So on the previous gen car, there wasn't a great deal of emphasis on downforce. Is that something that's changed on this, or is it still designed to be a playful drive?
Yeah, no, the brief in terms of how the car creates its grip is chiefly around mechanical grip, and I think the aero brief has been an evolution from what the previous generation was, which is about efficiency. So lightweight cars typically struggle with top speed, even though they have a very good power to weight ratio performance. This car now is up nearly at 585 brake horsepower per tonne, up from 525, for example. So for us, it's about making the car as efficient as we possibly can from an aero perspective. So that means minimising drag, but making sure that we do have downforce at high speed in order to make sure that the car is safe and that the car is trimmed and nice and stable. And that all starts from the front of the car, of course. That then feeds the air into the radiators, and then you'll notice that the rear wing the rear wing in profile has got a lot thinner. It's a lot more efficient, so that creates less drag. The diffuser, of course, works very well with the wing, so the wing doesn't move. Of course, it's how these two work in relation to each other. The diffuser strakes have been carried over, but again, optimised just to reduce the drag. So what we're talking about really is a car with a top speed of over 170 miles an hour, but with something that creates very efficient drag, but also gives a nice amount of downforce at high speed in order to keep the car nice and stable and nice and accessible.
Engine, I would argue, is probably the most significant change on this car.
I mean, after the appearance, for sure, the biggest change is the fact that after 9 years of being purists and naturally aspirated, we've moved towards forced induction. Obviously, forced induction is the way that most manufacturers are moving to now in order to meet the emission regulations, and obviously we recognise that too. So the big headline with the engine is that this is EU6D emission compliant, which means we can sell the car in mainland Europe and around other territories around the world. So it's a huge elevator in that sense. But in terms of the appearance, the air is no longer fed in. As with the previous generation, the air was fed in above the top of the car through a filtration system and then down into an airbox. We now have the airbox that's positioned on the side of the car, and because the engine is turbocharged, and most turbocharged engines are designed to sit in cars that are transverse mounted front-wheel drive traditionally. So how we get air from one side of the car into the intercooler that's based on this side of the car, there's been some very, very clever packaging work that's been done by the team in order to get the air in, obviously through the intercooler, into the turbocharger, and then obviously produce the power that the engine makes, which the headline figure is 332 brake horsepower, so that's up by 27.
And it weighs...
The engine is slightly heavier from the previous normally aspirated version, obviously because of the turbocharger and the ancillaries that are fitted, but because of the meticulous attention to detail and the weight reduction that we've been on with the bodywork and other different areas, the headline figure of the car is that it's actually 10 kilos lighter. The net is that it's 10 kilos lighter. So with that weight save and with that power increase, the headline figure is from 525 up to 585, so it's a huge, and of course the big thing is that this car produces over 400 Newton meters of torque now.
So as a result of going turbocharged, then you've benefited from all of that torque.
Yeah, absolutely.
Which in something so light must be an amazing feeling.
Well, it is, and I think the key thing really is to understand how we've worked to match the torque delivery and the power delivery to give a normally aspirated power delivery feel. Right. Because of course, the lighter the car is, the more apparent that power delivery is.
Sure.
So it's really, really important of how we've managed to match that power delivery with the weight of the car.
So, speaking of saving weight, run us through these wheels. I would call them an alloy, but I think it's a disservice. You guys refer to them as a carbon hybrid wheel. You were explaining earlier on, but it was like you were talking to me about a science project. so explain the amount of work that's involved in these.
So this is our carbon hybrid rim, and the reason why we call it a carbon hybrid is because we use the right material for the right applications. So we all remember, or maybe we don't, physics, our physics A levels, I equals mr squared. So where we try and save the weight is most important on the rim, because it's to the power 2. So the rim is made of carbon. Carbon isn't that great in bending, and so in order to try and optimize the wheel centerpiece, we've used forged billeted aluminium, because aluminium obviously is much stronger in the axial direction, obviously for the impacts as well. It means we can go to much thinner sections and we can save more weight. Now that wheel we launched about 4 years ago. It's been very successful for us. It's our option wheel. It's 2 kilos lighter than our standard alloy wheel, which is actually the lightest 17-inch alloy wheel in the world. So already we were pushing the boundaries of light weighting, but we've really gone to the next level with this one. So this has been a collaborative project with our friends at Autodesk, who are our software collaborator. We've been working with Autodesk for the last 5 years, and this is all around generative design. And so what generative design does, it basically looks at the load cases that are applied, in this case to the wheel, whether it's impacts, axial loads, etc. And what it's trying to do is it's doing continuous FEA analysis, and it's looking at the areas that it can save weight. Once it's taken weight out, it's then reanalyzing the FEA, and it's doing that so many times throughout the entire process. And the net is that we've ended up with a wheel that is 1.22 kilos light, it's almost 1.25 kilos lighter than the existing wheel.
That was already the world's lightest 17-inch.
That's right, which is the carbon hybrid, which was 2 kilos lighter than the lightest alloy wheel. So we're really pushing the boundaries. But I think the real clever thing with the wheel project is that it's driven by a big aesthetic, so it has to work on the car, it has to work in the context of the other components around it, and that's why it's been a real revelation to work with the team at Autodesk, and our innovation team have worked very, very closely with them, because you can restrict certain surfaces so that we've maintained the appearance of the previous version of the wheel, and that's why it started to adopt these more organic shapes.
When you get up close to it, the amount of sculpture it's got on it. But all of this is purely down to the system going, we can save weight here because we don't need strength there?
Exactly, but it's optimizing all the time. And the thing is, because Autodesk also write the software for the machine that makes this, so in this case it's a 5-axis CNC machine, the algorithm's constantly saying, how am I going to make it? What's my load case, and how can I save weight, and doing all of this analysis. And at the same time, it's working with the restraints from our design team, who have said, no, we need to maintain certain surfaces in certain areas from an aesthetic perspective. And then we get the result, and then it's a question of then honing the result to make sure that from an aesthetic perspective the guys were happy with it, that we could still machine it and make it, and the result is this. And it really is, it's been a huge success, and it sits very well next to our new brakes from our friends at AP Racing. And they've also been on a diet as well. So if you look at the calipers, the calipers are also heavily pocketed, and they've also been designed with generative design, and they're also lighter than the previous versions. So they're almost 300 grams lighter than the previous calipers. The valve is even lighter as well. I love this.
So this is honestly, I mean, as nerdy as it is, I think when you start speaking about smaller components or going into such minute detail on small components, I think that tells more of a story about the ethos of the whole car. Once you understand that mindset of your brand, I think it gives you a completely different appreciation for the amount of work that's involved in this car.
Yeah, no, I think so, and it's going to be great to have see the car on the stand at the Geneva Auto Show. Because you'll have the current car which we're producing, and we will produce it for the next 12 months. Obviously, this car is on sale right now, but first deliveries won't be until summer, Q3 of 2021. And so, yeah, I think what it does is it shows that evolution, it shows the attention to detail. Obviously, there was the revolution that created the original car. It'd be great to see the cars sat side by side on the stand so people can compare the old with the new.
So driving experience. Last time I drove a mono was around Silverstone. How will it differ? What do you think will be the main characteristic changes between the naturally aspirated drive and this car?
So because this engine's turbocharged, it won't rev as high. So you won't have quite the orchestra of 8,000 RPM red line. Having said that, what you will get is a significantly bigger push through the torque and the power that the engine's got. What we've tried to do is match the power and torque delivery to give a normally aspirated feel. So as opposed to normal turbo sort of flat torque curve, what we've tried to do is get a nice progressive torque feel, so sort of Ferrari 488 type feel.
Brilliant.
So you'll still have that accessible power, that linearity of performance, but what you'll get is just everything will just be on the next level. We now have a range of slick tyres, so you can start to learn to drive on. I think you drove on the standard road tyre of the previous car, which was Kumo.
Interior. I mean, it's funny to call a single seater having an interior, but has much evolved?
Yeah, so we've changed quite a few components on the interior. Interior carbon side panels are now an option. The steering wheel has changed in design, so you'll notice that the perimeter of the steering wheel has now got this more kind of Formula One-esque type shape to it that you'll see on the top and the bottom. But in essence, there's a new interface as well, slightly, so we've got a different screen now on the interface. It's all to do with things like brake bias and information that the driver gets. It's to basically help people get to know the car, to learn the car, and then obviously as part of the ownership experience, improve their driving and their performance on track specifically in some cases. There's been some packaging changes that we've had as well. So because of the front lights, we've moved the battery towards the centre of the car, and things like polar, without getting too nerdy again, polar moments of inertia have changed, so that we've centralised more of that mass, so that helps for rotation at the apex, and it improves lap times as well. So,
speaking of ownership experience, I wouldn't normally talk about the attire you're wearing, but not only have you developed your own car, you've developed your own driver wear.
Yes, we have. So we firmly believe in the fact that driving is a sport, it's a hobby, and that therefore there needs to be clothing that's designed specifically for it. And so obviously, because the car is open top, we need to make sure that if people get wet, that they're obviously waterproof, but also we need to make sure that, as you know, when driving, and particularly when you're on track, that you can sweat and you can perspire. It can be quite a physical thing. So we've developed with our friends at Gore-Tex and at KTC, who manufacture the jackets, for example, we've developed this jacket that I'm wearing, obviously because the cockpit is a restricted area, and practical things like keys that fall out your pockets and coins and so on and so forth. So the pockets work reverse. It means you can access things when you're sat in the car. The key fob for the car is in the arm here, so when you get in the car, it knows that you're there. You just press start and off you go. It's a great security thing as well. It's fully waterproof, it's fully windproof. It means because the harnesses are when they're in position, the pockets are positioned so you can still access everything. It's just given this thought, like there is to mountain biking, like there is to skiing and snowboarding. That there's wear that's been designed, and I think it's great that this is in line with the new car, because we're launching this new merchandise to go with it, and a new website. So go check it out.
Great stuff. I assume you've still maintained the storage space?
We have. Yeah, the main storage thing is at the front, and actually what you also apparently used to be the latch that was here.
Yeah, that's right.
So this is now released via a button on the interior.
Okay.
The bonnet comes up. We've got this lovely trimmed interior space here now. We've always had this storage space at the front, but because we had the latch, we used to have this arm that came in here now that restricted what you could put in here and how much usable space. So it just, again, a little evolution of the previous version. We've still got the storage tray there up at the top for other elements. But you'll notice this component here, which is, this is actually an additive manufacturing part. And that starts another story and a journey that we've been on. The whole latch mechanism, apart from the metallic elements, is all 3D printed, as is the striker. And that's part of an additive manufacturing process that we've been on for probably about the last 2 years. And because of our volume, additive manufacturing has a real relevance to us, because it means that we've got a flexibility of design. It means that we can make improvements and changes in a very short period of time. We can print parts ourselves. And so for the first time in our history, we've actually become a supplier of parts.
Really?
As opposed to using our supply chain. Yeah, so as an example, the wing mirrors, these are all 3D printed. The arms are 3D printed, the actual housing is 3D printed. There's about 41 different components on this car that are 3D printed. And now 3D printing used to be the realms of a rapid prototype. So in a design environment, you'd make a mock-up of a part, you'd look at it on a car, and then you'd go away, tool it in plastic or metal or whatever. There's been some really big strides forward with materials called Novamid, which is a carbon-filled material. Don't get too nerdy again, but it means that you've got a structural property now to these 3D printed parts, as opposed to just an aesthetic part you could try on the car and check out its appearance, for example.
Wow. Fantastic. Well, we've had a really exclusive look here. The next time I'll be seeing this will be on the stand at Geneva.
We look forward to seeing you.
I'll be there. Congratulations. Thanks a lot, mate. Cheers.